Welcome to the fifth session of the module 4. Now, in the previous class, we have differentiated between soldering, brazing, and welding. So, soon after that, we have also discussed about the belt drives. So, basically, we have also discussed the different types of belts and the belt that is being made up of different materials can be used. It may be made up of thermoplastic or it may be made up of metals and even the fabrics and leathers and rubber. Whenever we hear a sound of flexible materials, then we always feel the leather and rubber and fabric materials are better. It's only because they will have a higher flexibility and they can come back because their elastic nature is good. Elasticity property, they possess a good elastic properties so that it will come back to its original shape after this. It's only keeping in mind that the belt drives will always experience continuously between a tension and a compression. So a material which should resist both the tensile stresses as well as the compressive stresses are being selected as the better material for that. So even the cotton and fabric will also be used, but when we say it as a plastics, so polyester and polyethylene are the better materials compared to the other rest of the materials. In the two pulley systems, actually, the belt can it either drive the pulley normally in one direction or it may be in the opposite directions. But the belt may be crossed. It has to be crossed in the otherwise, so that the direction of the driven shaft is being reversed. As a source of motion, a conveyor belt is one application where the belt is been adapted to carry a load continuously between 2 points. As long as driver pulley will be rotating, the driven pulley keeps rotating. Once the driver pulley stops, then the driven pulley also stops. Okay. Now, I have also given an example of a chain between your bicycling pedaling as well as the back wheels of the bicycle, where the mode of the transfer will not be from the belt but it will be from the chain, but still the principle of operation remains to be same. Is that clear? Say for example, if you want to move it, the capacity of metal chains is much more than the belt materials, but chain materials cannot take the larger distance between the belt, the driving and driven pulleys. Whereas here in the belt drives, we can take more, the larger distance between driving and driven pulleys can be used. That is a major advantage over here. As a source of motion, actually, a conveyor belt is one application where the belt is been adapted to carry a load continuously between 2 points. The belt drives can also be used to change the speed of rotation either by up or down by using different sizes of the pulley. If the same size of the pulley has been used, then what happens, the same amount of the same number of speeds or the same quantity of the speed will be transmitted to the driven pulley. If you want more speed, then the driver pulley should be big and the driving pulley, the driven pulley should be small, so that what happens, if it makes one complete rotation, by the time this will make three revolutions or more. Is it clear? So that what happens, if it is rotating at 100 rpm, so this will be rotating at more than 100, maybe 150 or 200, based on the diameter ratio. That we will come to know that later. That is what we call it as a velocity ratio. If you want the speed to be less, then the driven pulley should have a larger diameter compared to the driving pulley. That is the that is the one advantage of this. Is it clear? So when it comes to the open belt drive and the closed belt drives, the open belt drive is one thing. I just talk about this belters in general. The connecting belt is being kept in tension so that the motion of one pulley is being transferred to the other without a slip. A slip is nothing but the belt which we have placed onto this driving or a driven pulley should not slip away. Is that clear? That should not slip away. For that, what they will do is they will have a small groove if possible, or else in most of the occasions they will not put even the grooves also or an extension that might damage the belt life. So so it will be most of the occasions it will be flat only, so the belt should not slip away. That is, if it slips there will be a loss of power transmission will be disturbed. Even if you can see this belt drives which will be often in the floor mills, you can see this belt drives. Okay. And even in the automobiles also, if you open your car bumper, wherein which there will be a V belt will be there in order to transmit the power. The speed of the driven shaft can be varied by varying the diameters of the two pulleys. That is what I meant to say. Now, basically, we just classify this into open belts, cross belt, and then V belt, timing belts, or we also call it as timing belt is also called as the grooved belts. The grooving is being done, or the gear belts. We also consider the gear belts. Okay, let us know what is this open belt drive. First and foremost thing is, in the open belt drive, what happens? The driven pulley will always have a same direction of rotation as of the driving pulley. If it is rotating in a clockwise direction, even the driven pulley will also rotate in the clockwise. If it is rotating in a clockwise direction, counterclockwise direction, this will also rotate in the counterclockwise directions. So the same direction in which both will be rotating. An open belt drive is used when the driven pulley is desired to be rotated in the same direction as a driving pulley. Generally, the center distance for the open belt drive is 14 to 16 meters. If the center distance is too large, the belt wipes, that is, the vibrates in the direction perpendicular to the direction of the motion. That means, if the belt, now this is a driving pulley and this is the driven pulley. In between the driving and driven pulley, there can be maximum 14 to 16. It is actually very big. 14 to 16 meters becomes almost 2 rooms of distance. Where if it more than 14 to 16, what happens? You can see the vibrations of this belt in the direction perpendicular to the motion. In vibrate upwards, it will move in the direction of the rotation. So this vibration leads to slipping, it leads to power loss, and it leads to a lower efficiency of this belt drive transmissions. Okay, now if the center is too long, the belt whips or the vibrates in the direction perpendicular to the direction of the motion. For every shorter center distances, the belt slip increases. Both these phenomena limited the use of the belt power transmissions. So slipping will also affect for a shorter distance. So it should not be too short also. It should not be too far away also. So there should be an identical, an optimized distance between driving and driven pulley should be maintained. That's it. While transmitting the power, now you can see this. While transmitting the power, one side of the belt is more tightened, known as a tight side, whereas the other side is being known as the loose side, or it may be called as a slack side. In case of the horizontal drives, it is always desired that the tight side is at the lower side of the two pulleys, whereas the uh, sag, or it may be a slack side of the belt, will be always more on the upper side than the lower side. It's only because, my dear friends, you just imagine, now there is a driving pulley whose diameter is less, the driven pulley whose diameter is more. What does it mean? That means this power transmission is to minimize the rotary motion. That means the driving pulley will be moving or rotating faster than the driven pulley. Driven pulley rotation is less. Say, for example, if the driving pulley is making 100 revolutions per minute, whereas the driven pulley will be making less than maybe 85 or 90 or 95, but it will be less than the driving pulley. Is it clear? Now this thickness of the belt will be based on the application. Various factors are there. Based on that, the thickness of the belt will be decided, but it will also have a minimum thickness of so much should be maintained. If you see the inner side and outer side of this, the inner side is the one which will be in a physical contact with the driving as well as the driven pulley, whereas the outer surface is the one which will be exposed to the atmosphere, and where this outer face will not be in contact with the pulleys at any cost. So that what happens, only the inner face, inner surface of the belt will be exposed to the friction. It will be exposed because it is making the contact, right? If you take like this surface is not making any contact with the pulley, only the inside surface is then experiencing this friction. Whenever it is experiencing friction, the chances of now it is not the chances, it will experience the heat, it will also experience the friction. That means the failure of the belt may be more from the inner side. So what they will do it is, they will make it as a alternative applications. If the first time they will use it like this, and the next time they will use it like this, because the complete material will be made up of a same material, isn't it? The complete the belt is made up of a same material. Now you just take this. This is an effective radius of the driving pulley, and this is an effective radius of the driven pulley. Now if you observe it here, the belt which is at the bottom, where we have mentioned the inner face and outer face, is called as a tight side, whereas the above portion, which is shown it as with the thickness, will be a slack side. It is only because we are just pulling. We are just pulling means we are. You just imagine we are just pulling it like this, and we are leaving it to the at the top of the pulleys. That is under driving or a driven pulley. So what happens when we are pulling forces from the bottom side? This experiences more tension or the force or a pressure. So this is what we call it as a tight side, and comparatively tight side, the upper portion will also have a loose or a little bit free, not completely, a little bit free compared to the tight side. So it is called as a slack side, slack, slack side of the material. So while it is the same material, when it is going downwards, it will experience the tight side, that is more tensions, whereas when it comes to the surface, or when it passes through the one pulley, then it will be experiencing a slack side of the belt. This is because the slack side of the belt will be more on the upper side than the lower side. This slightly increases the angles of wrap of the belt on two pulleys than if the belt had been perfectly straight between the pulleys. In case of the tight side is at the upper side, in case if it is at the upper side, then what happens? The slack side will be greater at the lower side, reducing the angle of wrap and the slip could occur earlier. This ultimately affects the power of the effects of the power to be transmitted now. No, because of the 90% of the time, in most of the occasions, the slack side will be on the top and the tight side will be on the bottom. Okay, so this is the one cross belt drives. Cross belt drives, now as you can see it here in this figure itself, in the cross belt drives, what happens? The direction of, whenever see in the open belt drives, what happens? In the open belt drives, the same direction of rotation will be used. In uh, the crossed belt, the direction of rotation will be different than the driver pulley. That means a driven pulley will always rotate in opposite direction compared to the driving pulley. That is the idea behind of using a crossed belt drives. Basically what happens, this belt friction does depends upon the friction that which operates, but excessive friction wastes the energy and also rapidly wears out the belt with higher temperatures. Factors that affect this belt friction includes the belt tension and contact angle. Now, because the contact angle and the belt friction tension will be more here in this cross belt, so the cross belts will wear out much faster compared to the open belt drives. A cross belt drive is adopted when the driven pulley is to be rotated in the opposite direction or in the reverse direction to that of driving pulley. A cross belt driven can transmit more power than the open belt drives, as an angle of wrap is more. Angle of wrap means if it is something like this, it will holds it more. That is the one advantage. The only thing is it has a higher angle of wrap so that it can transmit more power. But what happens since it is a crossed one, the percentage of slip is more in crossed belt. It's a common sense. Okay, the percentage of uh, slip is more in cross belt drives compared to the open belt drives. And more of since because it is a cross, somewhere if it touches the belt itself will also loses its life, reduces its life because of that. And these cross belts are effective only when the distance between the two pulleys are less. Whereas in the open belt it can go up to 16 meters, 14 to 16 meters it can go up to that. Whereas this cross belt drives cannot go up to that distance. Okay, now the slippage is more, so obviously the power transmission or maybe the power loss will be more. Okay, however, the belt has to bend in two different planes and it wears out more. The life of that is what I just want to say. The life of the belt which is being used in the cross belt will be less compared to the life of an open belt drives. But because certain occasions when we have to reverse the directions, then we will use this cross belt drives. Is it clear? Now, even there are a few things. You might have seen a cycling equipment, not our bicycles, cycling equipment. When you when you pedal it, you can rotate in the same directions. If you rotate in the opposite direction, it doesn't rotate the back wheels, isn't it? So that is such kind of different applications will be there for the cross belt as well as the open belt drives. Now let me talk about the velocity ratio. T is nothing but the thickness actually. Now velocity ratio is one of the important factor which has to be discussed. It's only because the amount of rotation or the energy that transmits is more important in the belt drives, isn't it? So that is the reason why we always discuss this velocity ratio with respect to the thickness as well as the diameter of the pulleys. Because of the flat belts which tend to climb towards the higher side of the pulleys, pulleys were meant to slightly coax so that there might be a little drop down in the velocity also certain occasions. Now let us take this velocity ratio which is given by VR is the ratio of the speed of the driven pulley to the driving pulley. Now there will be always the two pulleys unless otherwise we have a jockey pulley. Jockey pulley is the one which is being used in order to make the slack side into tight side so that the slip will be up. Slip percentage should be reduced. Is that clear? Now, if N1, N suffix 1 is the rotational speed of the driving shaft and N2 is the rotational speed of the driven shaft. Now we have a driving shaft and we have a driven shaft. This driving shaft pulley is nothing but N1 and this driven shaft pulley is N2. The diameter of the driving pulley is D1 and the diameter of the driven pulley is D2. Thickness of the belt is given by T. T is equal to thickness of the belt. Neglecting any slip between the belt and the pulleys. That means we are not considering the slipness factor. Basically, slip factor should also be added over here in the next equation. I'll show you. Neglecting any slip between the belt and the pulleys and also considering the belt to be inelastic, assuming it has to be inelastic. Okay, speed of the belt on driving pulley is equal to speed of the belt on the driven pulley, which is given by d1 plus 2 into t divided by 2. Why it is being taken t divided by 2 is, now if you see the sketch, the thickness is nothing but a t. if I make it as a T divided by 2, so only we were taking half of the belt thickness. We are taking only half of the belt thickness, which is making a contact with this here and making the contact with over here. Are you getting my point? If you have a circular one, it is something circular. It is like this. Now the T by 2 and the T by 2. So it comes to be T, that is nothing but the thickness of the belt, which is in touch. Which is in touch I am talking about. T by 2 in the top and the T by 2 at the bottom. So T by 2 plus T by 2, that is 2 will also get cancelled. 2 into T by 2, which gives rise to N1. Okay, now this is the thickness, which is thickness of the belt, which is in touch with the pulley, and then N1 is the speed of the driving pulley. Whereas here for the driven pulley, D2 plus 2 into T2 into N2. So that gives us the speed of the belt on the driven pulley. So on cancelling all those things, we just always get 2 will get cancelled and left out with thickness of the belt with the T. So that velocity ratio is equal to N2 divided by N1. That is the speed of the speed of the driving pulley, which is equals to the diameter or the diameter of the pulley plus the thickness of the belt of the driving pulley to the diameter of the driven pulley plus the thickness of the belt. So in other words, if you neglect the thickness, it is nothing but N2 divided by N1 is equal to D1 ratio is directly proportional, inversely proportional to the diameter ratios. Is it clear? So based on this also we can find out what is the speed with which it is. Diameter, however, it is not varying. However, diameter remains the same thing. Okay, by increasing any one speed, we can also make the other speed also vary according to that. Okay. Now the other important factor is slip. Slip. The effect of a slip is to decrease the effect of the slip is to decrease the speed of the belt on driving shaft and to decrease the speed of the driven shaft. Let omega 1 be the angular velocity of the driving pulley and omega 2 be the angular velocity of the driven pulley, and S1 is nothing but the percentage of slip between driving pulley and to the belt, and S2 is nothing but the percentage of slip between driven pulley and the belt, and S can be denoted with the overall percentage of the slip that might occur. Okay, so that is the slip. Basically this slip is majorly occurs because of the speed variations, sudden load variations, that leads to the slippages to occur. Now basically what happens with this slip is majorly occurs because of which leads to reduction in the speed of the belts, and also it reduces the transmission. The power transmission will also be reduced because of the slippages that might occur in the belts. Now peripheral speed of the driving pulley is given by peripheral speed, it is given by omega 1 into d1 plus t divided by 2. Speed of the belt on the driving pulley is given by omega 1 into d1 plus t divided by 2 into 100 minus s1 divided by 100. That is nothing but the percentage of slip that occurs majorly in the driving pulley and the belt. Whereas this is also the similarly we can also give it for the peripheral speed of the driven pulley, which is given by omega 1 plus d1 plus t divided by 2 into 100 minus s1 divided by 100 into 100 minus s2 into 100 divided by 100. That will give rise to peripheral speed of the driven pulley. Thus the s is nothing but the total percentage of the slip, which is given by omega omega 1 into d1 plus t divided by 2 into 100 minus s, which is nothing but the total percentage of the slip. The total percentage of the slip. That means if a driving pulley rotates 100 times, obviously the driven pulley, assuming if it is of the same thing, some x times it will rotate. If it is rotating at 100 times, what is the percentage of slip? Maybe one time, maybe 1% or 2% or the 3%. So then the slip factor will be taken as the 3 divided by 100 also. The simplifying equations can also be simplified. This equation can also be simplified into omega 1 into t1 plus t divided by 2 into s also. Okay, that will give rise a peripheral speed of the driven shaft. Now one more important terminology which is related to the belt drives, it is the creep. Creep is one of the important factor that is being considered. Actually, it is expressed as a percentage also. An effect on the velocity ratio. A result of a belt slipping is to reduce the velocity of the ratio of the system. Creep in the belt is defined as when the belt passes from the slack side. Assume the slack side is at the top and the tight side is at the bottom. When the belt passes through the slack side to the tight side, the certain portion of the belt extends. When it has been extends, see for example, when you are pulling it, obviously it is something like a tensile strength. Tensile strength means it is an extension, correct? Since it is elastic, if I release that, it will go back. Are you getting my point? So whenever I pull this, once again it extends. Whenever I release it, it will go back. Because of the elastic property, it doesn't notice physically, but it will undergo. Okay, whenever that belt passes from the slack side to the slight tight side, a certain portion of the belt, only the portion, certain portion which is in contact with that pulley and which is just releasing that, will experience an extension, and it contracts again, and it just contracts and it comes back again when the belt passes from tight side to the slack side. No, the tight side and the slack side. So that makes a creep. Basically, this creep in a friction drive power transmission systems comes when the drive moves slightly faster than the belt. Is it clear? So, as we just can see it in the previous open belt drives itself, where the power transmits at the effective arc, which is also called as an angle of creep. That I just shall I'll show you in the next sketch. The angle of creep. This is what we call it as an angle of creep. This is what we call it as an angle of creep. Is it clear? Now, if you take this, if you, I just shall demonstrate it with the older figure. Now here, the above one is the slack side and the below one is the tight side. Now, please be careful here. If from the point of driving pulley, when this driving pulley is taking this bottom tight side uh, material or a belt, what is happening? It is been extended. At the tight side of the belt, it will be extended little amount. But the same belt, when it passes through the driving pulley, when it comes away with the physical contact of the driving pulley, the slack side, it becomes a slack side. So that what happens, it just relaxes. It has been extended little bit and then it relaxes. So once again, when it comes in contact with the driven pulley, it will be extended once again and it becomes a tight side. Obviously, if you take a common sense, when I'm just pulling this, it is experiencing a tight set. When I just release it, it becomes a slack set. If you take a rubber band, no, this is a tight side and this is a slack side. It will experiences an extension and it will releases. So that is what happens as a creep. So that what happens, the material uh, experiences both tension as well as the normal forces, that is normal stresses. So that leads to uh, the variation in the forces or the pressure which is existing on the belts. So that is what we call it as a creep. If you take this compared with the slip, slip is nothing but an insufficient frictional grip because of the whenever it doesn't get a sufficient friction with the pulley surfaces, it will slip out. That is what we call it as a slip. It is because of insufficient frictional contact. That is what causes the slip with the driver or a driven belt with the belt. This motion of the belt relates to the driving or a driven pulley due to the unequal stretching of the two sides of the drive, which is known as the creep. Slip is because of the insufficient frictional gap or a grip, insufficient frictional grip between belt with the driving or driven pulley. Whereas the same belt, because of the motion of the belt relative to the driving and driven pulley, experiences unequal or insufficient or unequal, I'm so sorry, not insufficient, unequal expansion and relaxation, stretching and non-stretching of the two sides of the drive, which is known as the creep of the material. Is it clear? So that is the reason why the creep will also uh, experience, the creep plays a major role on the life of the belt drives. Okay, so next class we shall talk about the derivations.